All right, by the way, one thing to know is there's going to be another hacking workshop coming up there. Again, Friday and Saturday. So you can come to these things Friday and Saturday if you like. They're worth extra credit. The last one was a hit. And we'll do it again this weekend.
Chapter 2 also?
I think it's the same times, yeah.
Chapter 2 on Friday, Saturday.
Yeah. And I think maybe 9:30 on Saturday, something like that. The details are here. But they're the same as last week. Yeah. And so come to that if you're at all interested. No remote in the hacking workshop. You have to physically show up. A good question. Anyway, so we're up to Chapter 7. Right. And so let me start with the first bit of Chapter 7, which, I thought I had it open, but I'll open it now. There we go. All right. So let's get up to the start. Come on, here we go. All right, and get rid of this. All right. And there, that's a pretty good arrangement. Okay, so once again, I broke this chapter into 3 chunks. So here's the clues to tell you where one chunk is. We're just doing the first 2 topics here: exposing security model quirks and the first part of attacking application components. And so there's 3 main components when you use an app. There's the app itself on your phone, then there's the communication channels, and then there's the server. So the application container, remember your app runs in what's called the Android sandbox, which just means it runs with a user account that is not used by any other app on the phone, and the kernel separates its data from other apps for that reason. So you can defeat the application sandbox if you can gain access to the app data. And one way to do it is to put a malicious app on the device that reads the data from another app's data, in which case it would have to get a root exploit, physical access to a device, just steal the phone and read the SSD, and maybe other vulnerabilities in the app, like we saw there was a File Explorer app in the project I demonstrated last time that would just share all your files over an FTP port. So that would also defeat the security model. If it can get in the private areas, which it may not be able to without also an exploit. And then communications, of course. If you're sending network traffic, you can intercept it with ARP poisoning on a wireless network. You can host a malicious wireless network and just intercept it that way. You can compromise upstream providers. Any of these will put you in the path of the traffic. And then you can read and modify traffic, especially if it's not encrypted. So the internet server itself may have vulnerabilities. You can hack into the server and steal the stored data up there, and this happens all the time. Password dumps of millions of stolen passwords because they just hacked into the server. So let's talk about how the security model works. So inside Android apps, there are 4 components. There are activities, which are the visible pages you can see. There are broadcast receivers that listen for signals from outside the app. There are services that run some service and provide some facility for other apps, and then there's content providers, which are databases. And in earlier versions of Android, content providers were exported by default, which means they were available to every app on the phone by default. Now, nothing is available to share with other apps on the phone by default. You have to explicitly allow them, because this turned out, of course, to be a bad idea. And Amazon did the same thing. When Amazon first put up their cloud services, EC2, they made the database storages buckets by default visible to the whole world. And a whole bunch of companies put their data up there and didn't understand this and exposed all their data to the whole world. It was a very similar decision, which turned out to be a bad decision. So you determine, when you write an app, you specify in the manifest file the target SDK version. And that determines which one of these is going to be API 17 or less than 17 or 17 and greater. You choose it. And all right, there's other values. There's a compile version and the minimum version, which determine the minimum version determines the minimum Android version that your app will install on. Otherwise, you'll get a warning or it'll refuse to install at all. And one thing I mentioned before, I just went and looked up updated information for today. This is one incredibly huge problem with Android. Apple devices are usually running the latest version of their OS or maybe one version back. Android is very much different. Here's Android 15, 14, 13, 12. Here's Android 10. Here's less than 10. So you can see 14% of Android phones right now are more than 5 versions back. And that is really bad because, of course, these are vulnerable and they don't have the updates and patches for them anymore. This is a thing about Android phones. People buy phones. They usually don't update them. Often they can't update them. Their carrier doesn't provide updates, and they use them for years. So all these phones are vulnerable. Anyway, So you can decide whether you export a component. If you look in the manifest file, you can have a receiver here, like this, and then you say whether you want exported equal true or not. So this is explicitly exported. Now here is a provider that doesn't specify whether it's exported, so it will be exported if it's installed if it's target SDK version less than 17, but otherwise it won't. All right, and exported just means that other apps on the phone can see that and use it. Now, any component using an intent filter is exported by default because it's listening for signals from other apps on the phone. Therefore, it must be visible to other apps on the phone. So here's an intent filter, and the intent filter in here listens. If you send, the MIME type is going to be image. So it's going to, if someone sends an image, I think that means this can receive it. And it can do something with an image. So you'd have this for like an image viewer or something like that, where it's possible for someone to send an image over to it, perhaps from the stored photos or something. All right, so if you want to find these components, you look in the manifest, and let's take a look at the Civ app. I'm going to download it. Here's the Civ app is a demonstration app that came with a textbook. I think it's the textbook we're using, and it's a very vulnerable password manager. I'm not sure I'm using it in the projects anymore because it's kind of old and annoying. But anyway, it's good for this demonstration. So Android Studio. All right, you open up Android Studio, and if you want to examine an app, so far we just used Android Studio to run emulators, but you can also analyze an app. You just drag and drop an app on it, and it will take apart the app and let you see it. And so here, my application, I should see the manifest up here, and for some reason I'm not seeing it. That's annoying. I only see all this Gradle garbage. Android, all right, let me see if my instructions are going to help me here. Drag APK into the center pane of Android Studio, and on the left I should see stuff like classes.dex and such, and somehow I'm not seeing that. I must need to be in a different view. App, my application, this Gradle stuff, I've never understood this Gradle stuff. It's some other thing about Android apps. Let's see, Resource Manager, More Tool Windows, Project, Build. My application failed. Gradle version. The compatible Gradle version is this possible solution. Okay, it looks like I need to install more junk in my Android Studio to make this work or something. Okay, so I'm going to have to work on that. I don't know why it's not letting me examine this app, but I'll look at the pictures for the time being, and I'll try to figure out what nonsense is going on there. Anyway, what you're supposed to see is this. You're supposed to see the components of the app here. And by the way, let me cut to the chase. There is another way to do this, which is what I was showing Andrew last night. You can use this program called JADX GUI. And that will show us what we need to see here. This is another way to see inside apps, and it's very powerful. I should have it. Let's see. All right. All right, let me just do it now because it'll be more fun to do it live. Let me go to 128. There's a project where you install it. Somehow it's not on this machine, I guess. Oh, maybe it's not going to work on the M1. But down here somewhere is the MADHAR. M-A-A-D. There it is. Okay, this one here shows you how to install this JADX GUI. And here's how you put it on brew install. That's what I thought. Let me try the command line. Terminal. Okay, let's see if I already have it. JADX GUI. I don't. Okay, then I'll do brew install. I think it's just JADX, right? Yeah, JADX. There. That's all it should take. Let's see what it does. Now it's going to update Homebrew and all that. All right. So let me start with my images. This is what you'd see if my Android Studio is working correctly, which it isn't for some unknown reason. You'd see the components of the app here, the folders and files. You'd be able to click the manifest, and then you'd see the manifest file here. And here you see things like the intent filter and so on. You can see the properties of your app. And so in Civ, you'd see services here. There's an exported service, And here's a crypto service. There's a couple of services that are exported, crypto service and auth service. And here's the content providers. This is exported, a content provider, and here's another provider, and this one is also exported. So this password manager exports the database, and anyway, you can see in there some of the properties. And anyway, let me just take a look and see, okay, this is still running. All right, when that finishes, I'll do that same thing with JATX GUI, which is probably going to work better. Anyway, so there are high privilege users in Android. Root and system are the ones that can interact with any application component, even if they're not exported, just like root can go in any user's folder. And so if you don't export a component in the manifest, it's private. You can only use it internally for that app. And only attackers with root privileges can get in there. That's why, by the way, Android phones are not supposed to be sold rooted. So there should be no SU binary, so there's no way for you to escalate to root, and that wouldn't be able to perform those attacks unless you overcome that barrier. So the best recommended protection, if you define a new permission, is a signature, and that means only apps with the same signature can get in, and that would be only apps that come from the same company. So here's an interesting attack. The first app that defines a permissions protection level wins. Later apps that have the same permission can't change it. So what you could do is you could install a malicious app that defines the Skype activity, and then when you put on the real Skype app, it would have the wrong permissions. That was fixed in Android 5. And I had a project where people made old version emulators and ran it there. I don't know if I still have that, but it's probably not worth struggling too much. Anyway, that's now getting pretty out of date. Android 5 is not in common use anymore. Anyway, and then you can attack application components. Let me just take a look and see if this is done. Nope, still going. Okay. So an intent is a data object that is sent to send a signal to another app. So it defines a task to be performed. You do start activity intent, and that will send a signal to an app with a message. And you can send a broadcast intent that'll send to broadcast receivers. For example, if you click a URL, then it wants to open it in a browser. It will send a broadcast request saying, I have a web page to open. Who wants to open it? You might have multiple browsers on your machine. And so it might pop a box asking you which browser to use. Anyway, the intent is generic and doesn't specify the type of component receiving it. So here, if you pick photo in some gallery, it's then going to try to start some kind of app to show you the pictures, and then you'll select a photo and it will return that photo. So this code demonstrates how you can start another activity via an intent. I have an intent, and then I start the activity here. So it will send this signal and see if somebody can handle it. Now, the way it figures out what you're trying to do is from the scheme at the start of the intent. Now, you can also have an explicit intent that tells it which component must receive it. That's another way to do it if you, for example, are something like the Microsoft Office suite and you have several programs that you know about and you want to send a signal directly to one other program. But an implicit intent is more common, and that's where you launch something like an MP3 and you say, use any player that happens to be available that can handle this app. And the way that works is it works by the URL. This is an HTTP URL, so it's an HTTP is the scheme, and it will look for anybody that wants to render HTTP, and those will, of course, be browsers. So you can define, your apps can define intent filters, which say which intents your app is going to listen to and act on. And you can match the action, the data, or the category. So the scheme is the scheme of the URL. That's the part before the : / HTTPS and other things. That's one thing. You can have the host. You can look for intents only for a certain host. That's the google.com part of a URL. And the port is the port. That's the port number, which is usually 80 for HTTP and 443 for HTTPS. You can use a path prefix and path pattern. You can specify the intent just has to have this somewhere in the path. And you can also specify the type of data included in the intent to specify what you're going to listen to. So you can send intents from the command line with the activity manager. You do ADB shell and then activity manager start, and now you can send an intent action. This is sending a view action. And there's a lot of options here. You can send all sorts of intents. So you can send signals through Android Debug Bridge to poke apps and make them do things, and we'll be doing that in the projects. All right, so here's some real-world examples of these things. For example, the device lock screen here requires a password, but there's an exploit that bypasses that and shows you the desktop. A way to bypass the password login. That was an Android version less than 4.4. You could just send this intent you see here. You could send an intent in ADB, and that would unlock the phone without you knowing the PIN. This is like insecure direct object reference. You can get right to the next page without passing the supposed security barrier in front of it. Tap jacking is another one. This is a general attack called UI redress, where you display a screen and trick the user into interacting with it, but they're seeing something false. So they're clicking on something, but they don't see what they're really clicking on. So you put a false UI on top of buttons, so when you tap, it has an unexpected result. So here's an example. I could show you a game saying pop the balloons, click this balloon and click this balloon, and here you're downloading the app and approving all the permissions. But you don't see these pages, which are shown invisibly, and this page is put on top of it. That sort of thing, and there are many versions of this.
That's my personal favorite, and formerly, most people read it as a joke, but can't actually close the thing.
What's that?
It finally makes sense. It's my personal favorite. Most people don't understand that this is exactly what's happening when they try to exit out of an app.
Well, yes, and also, yes, and Microsoft did this, by the way. When they wanted to upgrade people, I think it was trying to force them to go from Windows 8 to Windows 10, but finally, after not enough people went up, they popped up a box and said, do you want to go to Windows 10, yes or no? And when you clicked no, it treated that as yes. And they can do that, and that kind of thing happens a lot. And by the way, the Trump campaign did this, and the Democrats did it for a while too, where they go to a donation page, and when you donate, there's like hidden text that says this is every month, and you don't know that. So you think you're donating once, but they keep taking every month. They call this whole thing is called dark patterns, the legal of making a web page that tricks you into doing something you don't want. And it's been around forever. AOL did this in the 80s. They would send you, or 90s, they would send you a disc in your newspaper that said join AOL, and you could easily run it and join and get your computer on the internet, but you could not get off. The only way to get off was to call them to cancel your account, and they carefully didn't have enough phone lines or operators, so you'd have to wait hours and you couldn't get through. This is a common trick. Anyway,
And it's technically illegal, but it's
it is. And it wasn't illegal. Now there are laws against it, and that's right. But people do it anyway. And so then there's recently used app screenshots. This is another thing that's troubling. When you close an app, you'll see it shrink down and vanish. And it does that by making a screenshot of the app and saving it like a thumbnail. And that is a picture of the way the app looked, and it might include your password or something else sensitive. So that's an issue, but it's stored in RAM and supposedly only available to privileged users. Then there's fragment injection on early versions of Android. If you used a fragment down here, choose lock password fragment, you could add this feature to run an activity, and you could change the PIN on the phone without knowing the old PIN. So another way to bypass the PIN lock. And that would just directly open this screen. See, you're supposed to have to log in with your PIN and then go to this screen to choose a new PIN. But again, it's insecure direct object access. You could skip over the first page and go to the second page to put in the new PIN. This is very common in security. You have a security barrier, but you don't actually block access to the thing on the other side of it. And you can just sort of go past the barrier to the secure page without passing through the test. It keeps on happening. Anyway, let's try a Kahoot, and then I'll try that JADX GUI. Oh, let me try the JADX GUI first. I think it's ready. Let's try JADX GUI. This is a fun, I'm not going to use this in the projects later. This is a very nice way to examine the contents of Android apps, and it's a graphical environment. So you just open an Android app. Now, I had one in my downloads folder called Civ. Okay. So when you open it, here it shows you the components of the app. And if you go in the resources, here's the digital signatures are in here. This is it's a certificate and so on. And I think it might still be processing, why I'm not seeing stuff over here. And you can see the source code here. And I'm not able to expand it, which I wanted to do. I think maybe it's still busy. Anyway, we'll come back to that after the Kahoots then. We'll see if time helps it work better. But this is a really nice way to examine what's inside an app. And maybe it's also going to give me trouble running on this processor. I'm not sure. let's try the Cahoots and see if I have more luck with that product. So here's the Cahoots. 7A, there we go. All right. All right.
I love these things.
Good, glad to hear it. Most people do.
At the same time, they try to make it
Yeah, they keep people from falling asleep. All right. Got 7 on mine and 2 here, so we should get 4 or 5 here anyway. What's that? You like the astronaut?
The astronaut is a nice middle here.
So I'm not getting it. I'm hearing an astronaut comic book or something. Yeah.
See the astronaut helmet on me? That's what he's talking about.
What's that?
He's talking about the astronaut helmet.
Oh, he is talking about an astronaut helmet. Okay, this happens to me a lot. I think I'm not understanding people, but I am hearing them. Okay. Oh, I see. Oh, okay, good. Thank you. Yeah. All right.
It's the helmets on planet Earth.
Yeah, it is kind of, yeah. All right. Oh, let's give it a shot. All right. So which command will send an intent? Yep, AM, Activity Manager. That's the command line thing that sends intents in Android command line. All right, which app components were exported by default in old Android versions? Content providers, which are the databases, just like Amazon, they figured that if you have a database, you must want that to be shared by everybody. A strange decision in both cases. But anyway, that's what they did. All right, which filter can match any part of the data? That's the path. Good. And, all right, which intent filter is at the start of a URI? Right, what do you call that? The part at the start of a URI like HTTPS. That's the scheme. Very good. All right. So, all right. 7AR. Yeah, and I think Oscar is the other guy's name. Yeah, I think this guy's name is actually gone. They're pretty close to that. Anyway, however, using a fake name is a good practice. You gotta figure out how.